Separate unlabelled solid samples, so let's just make a note of that because that's important, solid, of 3 anhydrous sodium compounds are provided for a student to identify. They're known to be sodium carbonate, so that's Na2CO3, carbonate's a 2- ion, sodium fluoride, NaF, and sodium chloride, but it's not known which sample is which. Outline a logical sequence of test tube reactions, so we're on a test tube scale, that the student could carry out to identify each compound. Include the observations the student would expect to make, give equations, including state symbols, for any reaction that would take place. So we're looking at our 3 things, and we notice that sodium's a common factor, so sodium is not a variable. So we're looking at testing negative ions. We've got 2 group 7 halide ions and a carbonate ion. So the carbonate ion is distinct from the group 7 ions. Let's remove the carbonate. So we need to think of a test for a carbonate, and the test for a carbonate is to add an acid. So let's say to a small, so maybe 1 centimetre cubed sample of each, well, not 1 centimetre cubed, they're solids, small, let's call it a small spatula. Of each solid. Add, we're going to add we need to choose an acid, 1 centimetre cubed of nitric acid. I like nitric acid for tests because nitrate ions don't give false positives with anything. So add 1 centimetre cubed of nitric acid. Whichever sample effervesces, so that's fizzes, effervesces, must be sodium carbonate, because carbonate ions react with the acid. So now we could either write an equation where we had the carbonate ions reacting with nitric acid. Acid plus carbonate makes salt, sodium nitrate, plus water, plus carbon dioxide. And then we could balance that. So 2 sodiums would give me 2 sodium nitrates, which means I'll need 2 nitric acids, and everything else will balance. Or I could do that ionically. The carbonate ions and the acid protons are going to react to make carbon dioxide and water. So that would be our first test. Now all we've got left are 2 sodium halide samples, but they contain different halide ions. So we remember that the test for halide ions is that if you add silver nitrate to a solution, then you'll get different coloured precipitates depending on the halide ion. But there is a little bit of a trick to that test. Because it's a test for a precipitate, we can't use these solid samples. So the first thing we need to do is dissolve a small spatula of each of the remaining solids in deionized water. Now, we need to be careful because if we hadn't have used deionized water, we could get false positives from carbonate ions in the water giving us silver carbonate, which is a white precipitate. But because we've used deionized water, we don't need to add acid to remove carbonates. Had we not used deionized water, then it would be essential to add acid to remove any carbonates in the water that might give us a false positive test here. So we dissolved it in a small spatula in deionized water. To each sample, add a small amount, so 1 centimetre cubed of silver nitrate solution, so aqueous silver nitrate. NaCl will give a white precipitate. So remember that is because the silver ions from silver nitrate react with the chloride ions to make silver chloride precipitate. NaF produces silver fluoride, and that is soluble, so it gives a colourless solution. So it will remain a colourless solution. Nothing visible is happening, and there is no equation to write. So let's just go back and have a look that we've answered everything. So we've identified the 3 by a sequence of tests, a logical sequence. We've included observations that we'd expect to see. We had to give state symbols with all our equations. So let's just double check that we put state symbols on everything. So I have on the bottom equation, but notice that I didn't on the top. We used aqueous. We had a solid sample, so we used solid sodium carbonate, but acids are aqueous. They would make an aqueous salt. Water's a liquid, and there's our effervescence gas. So if we wanted to put those on here, it's not really an appropriate ionic equation to have a solid carbonate ion, but it would dissolve on contact with the acid to be aqueous.